Okay, question 10, when we're asked to identify what kind of polymer it is and figure out what the monomer is. So you can see this first one is a polyamide, because there is the amide group there. That's CONH, so that tells you it's a polyamide, and that tells you it's a kind of condensation polymer. So I would say both of those things, because it's not really clear what the question means. So say it's a condensation polymer, specifically a polyamide. And you can see it's one of those where you have a pair of NHs separated just by a carbon chain. And therefore it's one of those formed from two different monomers. So from all that lot in the middle, you're going to get an amine group at each end, and then you just copy out the same thing that's already there, which, you know, is a bit tedious, but on the other hand you just keep having to tell yourself, well, these are easy marks because all I'm doing is copying to get these marks, so it's not such a painful thing to have to do. So that's the diamine that results in those two NH linkages. And you can see that the other thing, it looks a bit odd, because you think, well, I've got a carbonyl group there, and then if I feed round to the beginning of the next repeat unit, it's going to be another carbonyl there, an NH, and onto the rings and so on, like that. So the actual bit that produces the carbonyl groups is just that, and of course that means that it comes from ethane dioic acid, which is this. Okay, so those would be the two monomers. So that's your dicarboxylic acid, and that's your diamine. And that one just looks a little bit odd, but that's of course a common compound which you'll have come across elsewhere. Now this one is an addition polymer, and the way you know that is that you've got this continuous chain of carbons across the middle. So of course that makes it very easy, because the repeat unit is always just based around two of those carbons across the middle, like that. And you can see that's then repeated, and so the monomer is just the alkene that has those things attached to it. So the first carbon has the nitrile group attached to it, which is that, and a hydrogen, and the second one has this ester function here. So you have your COO methyl there, and again a hydrogen here. So that's straightforward as soon as you recognise that it is just an addition polymer. Right, so this one is a polyester again, because you can see that the carbonyl group there, if we read through into the next repeat unit, is going to read through into that oxygen, and then down here to the ring again, and so on. So you're going to have the ester group in the middle, so it's a polyester, and therefore the monomer is going to have alcohol and carboxylic acid groups. And you can see it's one of those where there's only one monomer, because you've got, that's the remains of a carboxylic acid group, that's the remains of an alcohol group, and they're both there within the same repeat unit. So to turn it into the monomer, we can cheat on the board here and just say, yeah, that was originally an alcohol group, and that was originally a carboxylic acid group, and that's it. So again, that's a polyester, a different kind of condensation polymer. This one, you can see again, is a polyester, and you can see an ester group in the middle there, but also that at the ends you're going to get COO, so another ester group there. So when it is deconstructed into its monomers, you're going to get two different monomers, one corresponding to this half, one corresponding to that half, separated where the ester group comes. So again, it's quite easy. If we just, as I say, deconstruct that, we're going to get OH here and OH there. So the carboxylic acid group from this monomer, and what's in fact a phenol group from this one, and then each of them also has its complementary functional group. So this has the phenol at this end, and therefore a carboxylic acid at this end, and this one has its phenol group there, and so there are your two monomers which condense together to give you that one. This one you can see is a polyamide, because you can see first of all there's the amide function in the middle, CONH, and then at the ends you'll have CO from this repeat unit feeding into the nitrogen, this time a secondary, or rather a tertiary nitrogen, from that end. So it's just a polyamide, and again you're going to get two monomers, because if we deconstruct it here, that comes from a carboxylic acid, and that comes from an NH2. Okay, so that's how we got that amide group in the middle there. So that's broken it into the two bits, and then again, to turn it back into the original monomers, that's just going to be NH at that end, and that's going to be COOH at that end. Because obviously when that then condenses with that, you get the linkers that we saw at the beginning. So those are your two monomers there. Now question 11 is just this sustainability issue with polymers that you need to know about. So it's just making the point that addition polymers, and in fact most condensation polymers as well, are not very biodegradable, which means that they're not broken down very easily by microorganisms in the environment. Specifically, in the exam you have to state that the condensation polymers, if they're not biodegradable, it's because they can't hydrolyze, because of course that's the way to break them down, but they don't hydrolyze easily in the environment. And of course the problem with that is that they build up in landfill and also in the oceans and cause problems to animal life there. So the idea is that biodegradable ones will break down into small molecules in the environment, and photodegradable ones will break down into small molecules in the presence of light, or maybe UV light, but just some kind of light. Okay, that's really all you need to know.